In this video, we present DCPViz, an interactive visual analytics approach for a variety of climate models' characterization of future climate for different emission scenarios. DCPViz introduces better accessibility and a streamlined environment for the climate scientists to analyze downscaled climate projection data. We demonstrate the interface in context to downscaled projections of precipitation and maximum temperature published by NASA Earth Exchange. DCPViz uses coordinated multiple views: temporal heat map, temporal geospatial contour matrix, map view, and summary view. The temporal heat map shows the historical mean precipitation for each month from 2036 to 2085. The monthly average precipitation helps the user understand the overall progression of precipitation over the time. The filtering allows the user to find a specific point of interest. To help the user detect fluctuations in precipitation, the relative precipitation option is provided, presenting relative precipitation that compares the current mean precipitation with the historical mean from 1985 to 2006. The temporal geospatial contour matrix consists of thumbnails of the geospatial contours sharing the identical axis with the temporal heat map. The thumbnails are the geospatial contour maps, and they provide a preview to identify their point of interest to the user. Clicking onto the thumbnail allows the user to investigate the contour map on the map view. The horizontal histogram on the right shows the yearly mean precipitation for each region. The color code for the bars are mapped with the region selection on the navigation bar. The map view shows a geospatial contour map that represents the precipitation intensity. The map view provides three interaction modes: inspection, selection, and annotation. The inspection mode allows the user to find areas having the same intensity level on the contour layer. The selection mode helps the user focus on specific locations by zooming into the selected location. The annotation mode allows the user to make an annotation on the point of interest. When the user makes an annotation, a marker is added on the map to indicate the annotation. In addition, a marker is added to the thumbnails in the temporal geospatial contour matrix view to indicate whether the annotation is there. The summary view shows the yearly averaged regional precipitation and maximum temperature grouped by season using three different visualizations: time series view, stack bar view, and hierarchical tree map. The time series view allows the user to explore the trends of projected values and to find anomalies and patterns in the timeline. The stack bar view is useful for comparing three RCP scenarios in a model. This view allows the scientist to identify the anomalies as well as to determine the projection spread within the RCP scenarios. The hierarchical tree map is a zoomable tree map in which the size of each cell represents precipitation and the color represents temperature. It allows the user to seek the relation in the yearly data by sorting on the tree map by year, precipitation, and temperature. DCPViz provides an option to expand and condense the interface. Enabling Expand reconfigures the coordinated views and provides additional visual components, such as historical trend and regional histogram for each season in the temporal heat map and temporal geospatial contour matrix view. Historical trends in between the heat map shows vertical lines with mean precipitation on blue line and mean maximum temperature on gray line. Regional histogram is the other visualization added beside each season in the expanded view. It plots the seasonal mean precipitation grouped by regions. With the interactive visual analytics interface and distributed computation infrastructure, DCPViz has potential to assist the climate scientists in their exploratory analysis tasks.